Thank you very much. Um, our association, Meters More, is an international non-profit association, and its main goal is to adopt, maintain, and evolve a Meters and More protocol communication, which is a power line communication protocol for smart grid solution. The main idea is to promote the existence of an entire range of interoperable devices, application and services, providing some services, for example, providing a certification process in order to assure that all the products are compliant. Another field is to evolve the protocol evolution. Our technology is field proven. There are more than 50 million meters in the world deployed. It is robust. It has been designed specifically for power line communication environment. It is efficient because data model and application layer are specifically designed to be as compact as possible, and is comprehensive of a series of companion standards to cover all the use cases. We can say that in the automatic meter reading is one of the most field proven. We have more than 15 million customers in the world, mainly in Europe, but also in Latin America. Our protocol, starting from the power line stack, so complete stack from data model, application layer, data link layer, and file layer over a PLC, evolved to TCP/IP public networks, but also evolved in the other direction with the support of COSM data model and DLMS application layer. Of course, the official specs are maintained by the Senelec, in Europe, and the focus on the evolution is on the interoperability. We did a tremendous job on the specification so far, and we are moving that effort to the certification in order to provide a robust infrastructure to guarantee interoperability among different vendors. Inside Meter More, we discussed a way to communicate between the meter and the home area network. We started from several use cases, so we tried to cover in-home display use case, home area network, simple PC access, usage of cloud services. And at the end, we relied on two key concepts. The first key concept is the gateway, which is a device, a logical device between the meter and the home area network. And the second concept is the meter to gateway interface, which is the only interface we specified. So you don't have specification between the gateway and the rest of the home. This is not our job. But we defined the interface between meter and gateway to be sure that the gateway can have all the information that home area network devices needs. Beside that, in Italy, there has been in 2016 specific movement that started from the Italian Authority for the Energy, ARERA, which asked to the Italian Electrical Committee to define a technical specification for the communication between the electricity meter and the end user device. The idea behind was to enable a full set of new services related to the end user awareness on the real-time consumption, the possibility to detect and signal anomalies, excessive consumption, risk of interruption, but also to allow the possibility to do some demand-side management, like load shifting or load detaching in case to avoid detachment from the network. This special channel has been called Chain 2. to differentiate between respect to chain 1, which is the one with the automatic meter infrastructure. The Italian electrical company came up with a specification. The technical specification foresee that at the lower layers we have the meters and more, layer 1 and layer 2, the convergence layer towards the DLMS COSM, and the LMS COSM application layer and data model. The idea is to use spontaneous, periodical, or event-driven compact frames, DLMS compact frames, to deliver the messages from the meter to the home. Which kind of data are foreseen to be sent from the meter to the home area network? There are specifically two kinds of messages. The periodical compact frames, which are frames which can be sent based on time. For example, every 15 minutes the meter can send to the home area network, to the user device, indeed, active and reactive energy. But the energy that you fed from to the network, that you draw from the network, or the one you are generating with your solar panels. The same for the active power, daily and monthly, for example, the total active and reactive energy. But another way to deliver messages and to deliver data to the end customer device is the event-driven messages. With these messages, it is possible, for example, to set up a certain level of threshold. For example, I set threshold every 300 watts in the power consumption, and the meter sends a message every time one of these thresholds is passed up, so that at the user device I'm able to rebuild completely a continuous load curve with the granularity of those thresholds, for example 300 watts, but I have a real-time load curve. It's possible also to generate commands, for example, when the power allocated is very, very close or even exceed the maximum load the maximum power permitted, in order to warn the customer that the user is to be detached from the network, or other things like the vendor change, the available power modification, the contract change, and so on. In order to cope with different use cases, the Italian Electric Committee defined the 3 service levels. The minimum, only essential use cases, like, for example, power consumption. Simple added values cases, so the basic profile, and advanced ones. And 4 types of users. One-phase users, consumer and prosumers, and 3-phase users, consumers and prosumers. Crossing those service levels and type of users, their user profiles have been defined, and each user profile corresponds to a predefined set of relevant data to be sent and a predefined set of triggering events. Almost more than 1 year ago, started a field trial decided by the authority. This field trial has been done in Italy with 100 users distributed in 12 different regions in Italy, with 37 users which had some potentially disturbing loads, such as photovoltaic inverters or strange loads and so on. He defined 3 kinds of messages to be sent, not the whole, let's say, all the possibility, but at least the periodical message every 15 minutes, the instantaneous power threshold, which means, as I said before, the threshold, for example, every 300 watts, and the power limit threshold. So the message that is sent when you pass the maximum allowed power and you are to be detached from the network. from the hardware point of view, there was one meter model, 5 different user device manufacturers provided by 7 user devices vendors. So during the field trial, also an interoperability check has been done. What were the results? The results were pretty good. After almost 1 year of trials, the requirement from the Italian authority was to have at least 90% of reachability. We reached between 98 to 99.4% reachability in all the conditions. And most important, this success rate was completely independent from building type, from user category, I mean commercial or private, from load condition, photovoltaic inverters or whatever. And the second result, which is remarkable in my opinion, is the average number of messages. In order to understand the scalability of solution, what could be important is to see how it scales with the complexity. If you look at S2 message types, on average, every meter exchanged during 1 year 886 messages with the end user devices, which means one message every 97 seconds. The maximum was 10 times more, which means one message every 10 seconds. So in the end, what to say? For sure, what we can say is that this experiment on the chain 2 confirmed that Meters and More is a viable, complete and affordable protocol suite, able to manage this kind of use cases and to give added value to the utilities and to the community. Just to remark that a big result from this experiment was that officially, I guess no more than 1 month ago, the Italian authority accepted those results and decided that they don't need to make any change to the specification. This specification is ready for the rollout, and this was, I think, the best recognition for this big effort. If you want more information, we have the Meters and More booth, which is very, very close to here, is 9N140. If you want to see live demo, you can look at the ST booth, which is also close to here. Thank you very much, and if you have questions, I'm here. Thank you.
Are there any questions from the audience? So if there are no questions, from me, so is it still, how much is still an experimental phase and how much is already up and running?
Let's say the experiment has been completed so far. Okay. So we can say it is ready to be deployed. Of course, it requires the new generation of meters, which is under deployment in Italy. I think that more than 50 million people already has in Italy these new meters. So I think in the next few years it will be more and more a reality.
And what are the biggest challenges you're expecting during this implementation phase?
I think to convince the user that this is an added value for them, because I think that the real big issue is to make the user understanding that having more awareness on the power consumption gives benefits also to them in terms of money, but also in terms of quality of life.
Okay. And how can we best convince or is that still too difficult?
I don't know, really.
Okay. Any other questions from the audience? Okay, then thank you very much.
Thank you.
See you.
Thank you.